We now graph g of x equals quantity x minus 3 squared times x minus 1 times x plus 4. This is also a product of linear factors, but we note that one of the factors happens to be squared. The graph is going to end up looking like this, but let's see how we get there. First place, we find our zeros. Okay, the zeros occur when g of x equals 0, and we see that the zeros are going to be 3, 1, and negative 4. Now, these are the same zeros we got in the preceding example, so you really kind of want to compare what happens with this graph with what happened to the graph in the preceding. Now, we also find our y-intercept. Now, our y-intercept before was 12, but now we've got one of the factors being squared, and that's going to change things. So if you plug x equals 0 in, what do you get? You get 3 squared times negative 1 times 4. Okay, that's negative 36. So the y-intercept is at 0, negative 36. So somehow squaring this x minus 3 moved our intercept from 12 down to negative 36. You might want to think about exactly why that happened. It's not that difficult to understand and worth thinking about. Okay. Now, we break the x-axis into the same intervals we did before. Negative 4 to negative infinity to negative 4, negative 4 to 1, 1 to 3, and 3 to infinity. I'm not going to go through the tests this time. On negative infinity, negative 4, we can conclude that the result is positive and gets really big, really, really fast as we move to the left. Now, I got that by putting in negative 100 for the x value. Think about it. You should pause. What do you get? What is your value of the function going to be close to if x is negative 100? And is it going to be positive or negative? Hopefully you paused and thought that through yourself. But if x is negative 100, then you've got to be squaring negative 103, multiplying that by negative 99, multiplying that by positive 96. All four of the numbers, well, this number is going to be close to 100. You're going to be squaring it. This is going to be close to 100. This is going to be close to 100. But they're going to also be negative because x is negative 100. So the magnitude of all these is 100. So when we square it, we get what? 100 squared is 10,000 times 100 is 1,000,000 times 100 is 100 million. So the value of the function is going to be 100 million. I think you're going to be out of the atmosphere on the scale of this graph. If you go over just 100 units, which is just over across the hall, probably in the next room, you're going to have to go up probably to orbital distances. And you see, of course, that you're squaring a negative and then multiplying a negative by a negative, making it positive. Okay, so on this interval, it's positive, really big, really fast as we move to the left. It's going to look like this. It's going to come down to 0 very fast. Okay, on negative 4, 1, what's it going to be? Well, it's going to be negative. We can tell that because of the negative 36 we get when x equals 0. We could choose another point, but choosing x equals 0 gives us negative 36, confirms that we're negative from here to here. So the graph so far looks something like this. Now, not clear what happens at 1, 0. Do we maybe turn around here, come down, go back through here, turn around, come up, turn around again, go down? We don't know. But if we evaluate on the interval 1, 3, probably using x equals 2, we'll find that, well, if x equals 2, this square is always positive, so really we only have to look at these two terms. 2 minus 1 is positive, and 2 plus 4 is positive. So that we have a positive result here, and the graph is going to come up above the x-axis, stay there between 1, x equals 1, and x equals 3. What happens then at x equals 3? Well, on 3 infinity, excuse me, let x be a big number. 100 is big enough. It's a lot further from the y-axis than 3. So if x is 100, then x minus 3 is pretty close to 100. X minus 1 is pretty close to 100. X plus 4 is pretty close to 100. These are all positive now, positive 100. So that product of four numbers, well, the square of a positive 100 times two other numbers that are each equal to 100 is going to give us like 100 million. Again, if we go out 100 units that way, we're going to have to go up again outside the atmosphere, okay? So the graph gets really big, really fast after we pass 3, 0. And then we have the shape of our graph. Now, I'll note a couple of other finer points on the graph, but I'll do that in a separate video. The finer points are pointed out in the red. They're interesting. They're important. But first, make sure we know how to do everything that we've seen here so far. Finding the intercepts, breaking the x-axis into the intervals, and testing on each interval, putting it all together into a sketch of the graph.